Today we're going to focus our attention on Chapter 3, Lesson 1, in which we're going to introduce ourselves to integer exponents. You should have a note sheet that goes along with this video, so please make sure you're filling out the note sheet as you go through the video. Feel free to pause at any time if you need to do that as well. The standard that we're working with is working with integer exponents. So the first thing that I have here is I have a table of exponents, all with a base of 10. So what I want us to see here is a pattern of what happens when we have a base of 10. So we'll start with 10 squared. We know that 10 squared is the same thing as 10 times 10. And if we multiply that out, we get an answer of 100. If we have 10 to the first power, what that means is we have 110. And there's nothing to multiply it with, so it stays as just 10. If we have 10 to the 0 power, we'll talk more later about what happens when we have a power of 0, but our answer here is 1, and then our result is also 1. We have nothing again to multiply with. Now when we get into the negative exponents, one thing that we're going to talk about today is what we do with negative exponents. And what we do is we know that 10 to the negative first power is the same thing as the fraction 1/10. So you can't have a negative exponent, so your 10 moves to the bottom of your fraction. Now 1/10 as a decimal is decimal 1/10. 10 to the negative second power is the same thing as 1 over 10 times 10. And when you multiply out 10 times 10, you get 100. So your answer here is either as a fraction of 1/100, or you can write it as a decimal, as decimal point 0.01. And then the last one, 10 to the negative third, is where you have 1 over 10 times 10 times 10. And if you multiply it out, you get 1,000 on the bottom. So what I want to look at is here we have a number 100. Here we have the number 10. Here we have the number 1. Here we have the decimal 1/10. Here we have the decimal 100th. And then finally we have the decimal of 1,000th. So what you may notice here is a pattern. So with 1 being our base, when we have a negative exponent, look at where my decimal was. It went from 1 to 1/10. So there's one number past the decimal. Here I have 10 to the negative second, and I have 2 digits past the decimal. Here I have 3. When I have positive exponents, my number, my answer, is a whole number. So we have 10, we have 100. Okay, we're going to work with those patterns today and see what happens and what transpires here. So these are just a few examples, all having a base of 10, meaning your big number is 10. So if I have 10 to the 7th power, what that means is 10 times 10 times 10 times 10 times 10 times 10, and we have 1, 2, 3, 4, 5, 6. Our exponent shows 7, so I need 7 tens. When I multiply that all out, I get an answer of 100,000. When I have 10 to the negative 4th power, remember, negative exponent means a fraction. So we have 10 times 10 times 10 times 10, but it's as a fraction. We moved it to the bottom because it's less than 0. So you multiply, or it's less than 1. You multiply those out, you get an answer of 1 over 10,000. What I want you to notice here is, here my exponent was 7. How many zeros did you have? Okay, here your exponent is negative 4, which means it turned into a fraction, but how many zeros do we have? Okay, let's see if that pattern continues on. So we have 10 to the negative 5th, turns into a fraction. Need 5 tens. I multiply it out, and I get 1 over 100,000. So does our pattern hold true? 5 as my exponent, 5 zeros. Yes, it does. That always works when your base is 10. Now, one thing that you noticed we were working with here is we had exponents that were negative. So one thing that you need to know is there's a rule with negative exponents. Any non-zero number raised to a negative power, meaning you can't have a big number of 0. So like you couldn't do 0 to the third power. That doesn't work. But any non-negative number raised to the power of with a negative raised to a negative power equals 1 divided by that number raised to the opposite. So when I have 5 to the negative third power, I have a negative exponent. So that means my numerator has to be 1, and then I put 5 to the third on the bottom. If I multiply out 5 times 5 times 5, I get an answer of 125. So my answer would be 1 over 125. In terms of algebra, if I were to use variables, what that means is if I had b to the negative nth power, my numerator becomes 1. My base was b, it moves to the bottom. And then now my exponent n is positive. So then that works if your b value is not 0. So b cannot be 0. Any other time it works. All right, so let's look at some examples. We have 10 to the second power. We know 10 to the second power is 10 times 10 results in 100. 4 to the third power means 4 times 4 times 4. You multiply that out, you get an answer of 64. Negative 3 to the negative second power. Notice that my negative 3 is inside parentheses. That's a huge thing. So because that's in parentheses, that means I'm taking negative 3 times negative 3, but it does turn into a fraction because my exponent was negative. So now what happens when you do a negative times a negative? It becomes positive. So I multiply negative 3 times negative 3. I get a positive answer of 1/9. So that's my final answer. Okay? Negative 5 to the fourth power. My exponent is positive, so because I'm in parentheses, I do negative 5 times negative 5 times negative 5. Now, I have a total of 4 negatives. Let's simplify this part first. Negative 5 times negative 5 is positive 25. Negative 5 over here times negative 5 is positive 25. So now we're doing 25 times 25 gives me an answer of positive 625. Now this next set of 4 problems I want you to pay close attention to because they all look very, very similar. But what you do with each of them is a different situation. So you have to identify, first of all, what is the base? And if the base is positive, you're good to go with just saying, all right, my exponent's negative. I know this needs to become a fraction. So it's going to become 1 over 2 times 2 times 2. Because with that negative exponent, you move it into a fraction. Now the 3 tells you that you're going to do 2 times 2 times 2. And then when you simplify it out, you end up getting 1/8 as your final answer. Okay. The second problem has a negative base, and it's in parentheses. So also notice my exponent is negative. So I need to first turn it into a fraction. And I'm going to write it as a fraction with an exponent. So then that tells me that I need to do negative 2 times negative 2 times negative 2. Not 3. Negative 2. So I have an exponent of 3. I'm going to see 3 negative 2's. Now, negative times negative is positive, so that gives me positive 4 here. But then positive 4 times negative 2 gives me negative 8. So my answer is negative 1/8. Okay? Now, this next example, notice the negative 2 is not in parentheses. So what this means is it's negative 2. The 2 is what is being raised to the power of 3, not the negative. So you have negative 2 times negative 2. I'm sorry, you have 2 times 2 times 2 with a negative attached out front. If you had parentheses, all three of those 2's would be negative, but we don't. So all three 2's are positive with one negative sign out in front. So 2 times 2 times 2 is 8, and then you have the negative out in front. Your answer is negative 8. Now on this next one, you have negative 2 inside parentheses. So now it's negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4, and 4 times negative 2 is negative 8. Now you might be saying, well, that didn't produce two different answers. You're right, because the exponent was negative. So what I want you to look at now is, what if I were solving this and my exponent was positive? So let me show you. For example, what if I had negative 2 to the 4th power versus negative 2 to the 4th power? So what this is going to tell me is I have 2 times 2 times 2 times 2 with one negative out in front. Multiply all my 2's together. I have 2 times 2 times 2 times 2, which gives me an answer of 16, and then the negative out in front. This one says, let's do negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is positive 4. And 4 times 4 is 16. So when your exponent's negative, or when your exponent's even, it really makes a big difference in what your final outcome is. So be careful. If you have parentheses around the base, like you do here, then the entire number is negative 2. But here, it's just 2 times 2 times 2. So make sure you're watching the base there. All right, and then the last thing is, anytime you have a base raised to a power of 0, your answer is always going to be 1. No matter what the base is, as long as the base is not 1, or as long as so if I have a cannot be 1, so I can't do 1 to the 1st power, because 1 to the 1st power is still 1. Okay, so that's not going to change anything. But as long as you have a number raised to the power of 0, your answer is going to be 1. So 2 to the 0 power is equal to 1. 3 to the 0 power is equal to 1. Now, I believe that this is an error up here. It should say a cannot be 0. And the reason for that is, if I do 0 to the power of 0, on your calculator, that's going to come up as an error. So that doesn't work. So that's the only time it doesn't work. But any other time, whether it's a fraction, whether it's a negative base, a positive base, anything to the power of 0 will always be 1. Okay. The next thing you need to do is you need to pick up a half sheet of homework from Mrs. Tompkins. There are 16 practice problems for you to work through that will be due tomorrow. So please see me for that half sheet. And if you have any questions, also check in with me.